All right, so today we're going to extend what we've done with the graphs, and we are going to first do an application, and then we're going to talk about what are called phase shifts. Okay, so the sine and the cosine functions, we can use those in real world phenomena such as sound waves. So you guys either have or will be talking about sound waves in science. And when you talk about those waves, you're going to learn about frequency. So frequency just means that it is the number of cycles in a given unit of time. So it is the number of cycles in a given unit of time. Okay, so it is the reciprocal of the period of a function. Okay, it is the reciprocal of the period of a function. So we're just going to write that down below. The frequency, if it's the reciprocal, it just means it's 1 over the period. So that's how you would calculate the frequency, 1 divided by the period. Okay, so hertz is the standard measure of a frequency, and what it measures is 1 cycle per second. Okay, so it represents 1 cycle per second. Okay, so a sound wave made by a tuning fork, which that might be something you guys remember from elementary school, when you guys did science, would they like play the tuning fork for you? So that has a frequency of 440 hertz. So this means that the wave is going to repeat 440 times in 1 second. Okay, so in example 1, it says use a sine function to graph a sound wave with a period of 0.002 seconds and an amplitude of 3 centimeters. And then we're going to have to find the frequency in hertz of the sound wave. Okay, so the first thing that we're going to do here is find the frequency. Okay, so if it's 1 over the period, we're given the period, and we're going to simplify this without our calculator. So we're going to do a full no calculator unit here. So what we can do is use what we know about place values. So this is the tenths, hundredths, this is the thousandths. So the fraction would be 2 thousandths. Okay, thousandths. And then if you have dividing, just remember, you keep, you change, you flip. So if you keep the 1, change to multiplication, and flip your fraction in the denominator, you just have 1,000 divided by 2, which is 500. And then it's measured in hertz, so 500 hertz. Okay, and then your amplitude that was given is 3. Okay, so we know that that's going to affect the max and the min. So if your amplitude is 3, your max value is 3, your min value is negative 3. Okay, and they gave you the period, which is 0.002. So that's what we're going to use to make our table. So just like we did yesterday, we are always going to start at what x value? 0. Okay, do you guys remember where we end? Nope. Well, yes for y, but yeah, you're going to end at your period. Okay, which in this case would be 0.002. Okay, but yes, because it's a sine function, when you start at 0, you are going to end at 0. Okay, so the y coordinates for both of those are going to be 0. And again, that's because they tell you it's sine. If it was cosine, you would start at the max and end at the max. Okay, so then we always do the halfway. Halfway between 0 and 0.002 is good. What do we know what is halfway between 0.001? Yes, great. You have an extra 0 in there. Okay, so I feel like sometimes things like that, it is helpful to have a visual. So if you have, it's really like you have 0.0010. And if you cut the 10 in half, it's 5, right? Okay, so you have to put another 0 there to represent that it's half of the 10. Okay? All right, so then really we're counting by 5 10,000ths. So this is 0.0005, 0.001, 0.0015. Great. Okay, and then for the sine function, you start at 0, you end at 0. Halfway is 0. Okay, and then if there's no reflection in between the first two intercepts, you reach the max. And in this case, our max is 3. And then halfway between the next two, you reach your min, which is negative 3. All right, so let's put our scale on our graph. And then I know I have to go up to 3, so I am going to scale my y's by 1. And then just like we've done in the past, oh, we can make this 0.002. I also have to tell you one more thing about the graph. Okay, so whenever you are graphing something that exists in the real world, you are only going to graph the positive x-axis, and that's because our period is represented in seconds. So the x-axis is going to be your time measured in seconds, and you aren't going to have a negative value of time. Okay? And then the y-axis is going to be our Hertz value, our output value. Okay, so go ahead and graph that. Again, when you're graphing for the real world, okay, and so you are just going to start here. You're not going to go past this. Okay, and then use your pencil to curve that through. Is anything else on yesterday? Yes, so you're only going to do an arrow on that right side. Okay, so 0, 0, halfway is 0, halfway is max, halfway is min. Okay, and then I always encourage you to start with the pencil when you're curving it through. Okay, yes, you have to connect those with the curve. And if you're having some trouble, I do recommend just like swooping it through 3 points at a time. Okay, it's more like a soft V here, not a complete U, because U's sometimes are wider. Okay, so make sure that you don't have any sharp edges there. Okay, so the next thing we're going to do is we are going to talk about phase shifts, which is just another way to say it's a horizontal shift. Okay, but they call it a phase because it's going to be affecting your period of your graph. So they give you these equations to show you what the form is. Y equals the sine of x minus h plus k, and y equals the cosine of x minus h plus k. So you might remember that if you have a vertical translation by k units, that's going to move the graph up or down. Okay, so if you have a vertical transformation, that's going to move up or down. If you have a phase shift, okay, that is a horizontal translation for a periodic function. Okay, so they call it a phase shift if it is a periodic function. Okay, and you have a phase shift of h units. That is going to move the graph left or right. And if you look at what's in parentheses here, it's saying that if you have a value where h is less than 0, that is going to be moving your graph, okay, to the left. So if it's a negative h, it moves it to the left. If it's a positive h, it's going to move it to the right. But look at what we have in our standard equation. We have this minus sign. Another way to interpret that is it's the opposite. So if you were to plug in a negative h value and it's already minus h, what happens is you have minus a negative, but we never keep it like that. We simplify, right? So if you have minus a negative, what do you see in the equation? You're going to see a positive. Okay, so in the equation, it's going to look the opposite. So if it's positive and you have that minus, okay, it's gonna look the opposite. So it looks opposite in the equation. Okay, so when we are doing these shifts with trig functions, you are going to combine some of the transformations, and we're going to use these values of a, b, and h, and k to identify some important features. So remember from earlier that a is going to be the amplitude. Okay, and amplitude always affects your max and your min. Okay, the other value that affects the max and the min is your k. So this is a vertical shift up or down. And I didn't put any of the vertical shifts in your homework because I thought that was too much. And now I'm thinking I should have, so maybe we'll do that. Okay, so this is going to affect the max and the min as well. Okay, so amplitude affects the vertical values, same thing with your k, which are your y values. Okay, and then your b value, that is going to affect the period. Remember to find the period, we do 2 pi divided by b. Okay, and then this is also going to affect your period just in a different way. Okay, so this is our phase shift. And this also affects your period. Okay, so yesterday we were dealing with different amplitudes and then different values of the period, and we saw how those affected the graph. Okay, today we're going to have phase shifts. Okay, and then before we start our graphing examples, let's make sure we understand what this is going to look like in a function. So we're going to write a cosine function that has a phase shift of pi. Okay, so if we write a cosine function with a phase shift of pi, that means your h value is pi. Okay, so we're going to write f of x equals, we're just going to make all the other values 1. So this is going to be the cosine of, if it's positive, what you would see is x minus pi. Okay, what that means is you move pi units right. Okay, now based on that, I want you guys to try this one. So write a sine function with the phase shift of negative pi over 2. Okay, so start by identifying your h value, and then let's plug it into our f of x, and then talk about where we're moving. Okay, so if your h value is a negative, when you plug that into the equation, your minus the negative is going to become a positive. So it's a negative pi over 2. So your f of x is the sine of x plus pi over 2. Okay, and in this case, you're moving pi over 2 units left. Okay, so essentially what we're going to do is we're going to take our graphs from yesterday, we're going to move them to the right, we're going to move them to the left. Okay? All right, so we are either going to use the sine or cosine as a guide, so our parent functions from yesterday. And then the difference is now we're going to identify the x-intercepts and the phase shift. Okay, we are also graphing. So that's the same as yesterday. Okay, but today our extension is going to be the phase shift and the x-intercepts. Okay, so the amplitude, if you do not see a number in front, because that's where your A value is, what is the A value? 1. Okay, so your amplitude A is equal to 1. Okay, your B value is either going to be in front of X or in front of the parentheses. Okay, in this case, you don't see it because it is 1. So to find the period, it's 2 pi over B. So 2 pi over 1 is going to be 2 pi. Okay, so your period is 2 pi, your amplitude is 1. Okay, now we are going to identify the phase shift. So because your value of H is, what is your H? Yep, positive pi over 4. Okay, that means your phase shift is pi over 4 radians to the right. Pi over 4 radians to the right. Okay, so that means all of the x-intercepts, the maxima, and the minima of that function, okay, are shifted pi over 4 units to the right. Okay, and the rule is if you are going to the right, you are going to add the phase shift to the period. And using our reasoning techniques, if it was going to the left, what would we do? We are going to subtract. That is correct. So I'm just going to say PS for phase shift. So subtract the phase shift from the period. Okay? All right. So what we're going to do is we are going to graph using our information about the function and those skills that we learned yesterday. You want at least 5 points in your table again. And then we also need to make sure we are labeling the scales of our graph. Now, in many cases, you can do the X scale. You're going to use the phase shift or the period divided by 4. Okay, you can decide which one you want to do. In this case, if we did 2 pi divided by 4, what would we get? Okay, sorry, you get the what over 4? So if you do 2 pi over 4, you get pi over 2, and then we would do every other one. For this one, we're going to do the phase shift. So we're going to go 1 pi over 4, 2 pi over 4, 3 pi over 4. We're going to keep that going. Before you guys start labeling that, will you see if you can find your start? So you're going to start at your phase shift. You write that down there. Okay, so what's your phase shift? Where are we going to start? Yep, at pi over 4. Okay, so we're going to start there. Okay, and then at the end, we are going to end at the period plus the phase shift. Okay, so yesterday we started at 0 and we ended at the period. Today we're applying the phase shift because 0 plus pi over 4 is pi over 4. So that's where we're starting now. Okay, so we're going to take the period, which is 2 pi, and we are going to add pi over 4. So I want you to do that. Okay, you can do it right at the bottom here where you have some room. Okay, so add 2 pi plus pi over 4. Yep, and then just write it down. And then I'll help you guys with the scale at the bottom. Yeah, just like if you come up with something better. Okay, so the 2 pi plus pi over 4, if you got a common denominator, you have 8 pi over 4, right? Times 4 plus pi over 4 is going to give you 9 pi over 4, so that's where you're going to end. Okay, how did that go? Okay, now anytime you're trying to find the halfway point, okay, when you have something halfway, you are finding the average. So when you're finding the average, you add things together and divide by 2. Okay, and there's a couple different ways that you can do this. I'm going to show you how to do it algebraically, but I'm also going to show you how to do it on the graph, which might be a little easier for some of you. So if you add pi over 4 plus 9 pi over 4, what do you get? Because we're finding the average. Yep, you have 10 pi over 4. What is 10 pi over 4 reduced to? 5 pi over 2. So on the top, you have 5 pi over 2 divided by 2, which is really just 5 pi over 2 times what? 1/2. So in the middle, we're going to put 5 pi over 4. Okay, so when you're finding the average, When we reduce it, you could even just do 10 pi over 4 times a half, okay, which would be 10 pi over 8, and that's going to reduce, okay? All right, we'll come back to this part. Let's start labeling these on our x-axis. So you have 1 pi over 4. What is 2 pi over 4 reduced to? Pi over 2. 3 pi over 4. What is 4 pi over 4 reduced to? Pi. Then this would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Generally, I label every other one. I don't label them all because I know that that's difficult to squeeze them all in there. Okay, the ones that I choose to label are usually the ones where you have your points. Okay, so this is negative pi over 4. On this side, it might be easier to like label some of these. So this would be negative pi over 2, the 3. This is negative pi. Negative 2 pi, because that's 8 pi over 4. Okay, so I'm going to show you a few things. So this is the sign. So for the sine function, your output value is going to be what for the start? 0. Okay, if you start at 0, you end at 0, and your halfway is 0. Okay, so on our graph, we're going to start at pi over 4, 0. We're going to end at 9 pi over 4, 0. And then 5 pi over 4, 0 is here. Okay, so you have these 3 points. So how many units are between each of these points? 4. Okay, so you have 4 units here, 4 units here, right? So 1, 2, 3, 4. So when I put the maximum, which I know is going to be 1 based on what I've done before, and I know this is going to be negative 1 because that has to be the min, right? If you're trying to find these values, you could add these together and divide by 2 again. You can do it algebraically, or what's halfway between 4 units? 2 units. So if you just go to 2 here, and then you're going to go up to 1, I'm going to, when I do this, I usually will scale by a half, scale my y's by a half. I think it's easier to graph it like that. And then if I go 2 units here, I'll be down at negative 1. So then can I just find that from my graph what those points are? So my max occurs at 3 pi over 4. So this is going to be 3 pi over 4. And then my min occurs at where? 7 pi over 4. So sometimes I think that's easier than doing your algebra, right? And then this is not an application, so we are going to span the full grid. So I want you to practice extending the pattern, and then we'll check that together. And I know some of you are going to pick up on this quickly, and you can start on step 4, but just make sure that you've labeled everything. And we definitely want to try it with pencil first. Okay, so 1, 2. So this, if you go 1, 2, you're at your max. So if you go the opposite way, 1, 2, you're at your min. And then 1, 2, intercept. 1, 2, max. 1, 2, intercept. 1, 2, min. Okay, again, if you notice that your waves aren't coming out as nicely, then just do 3 points at a time. These 3 points here, I'm just going to curve that through. Oh, it's so beautiful. And then this would be going up there. And then once you've done it in pencil, if you want to go over it in a color to make it stand out, you are welcome to do that. You do not have to do that. I like to do that on my notes just so you guys can see it. All right, and then I want you to answer that. Oh, well, I'm going to help you a little bit. So for the x-intercepts, it says, where is the first x-intercept? What I mean by that is find the first x-intercept on the positive x-axis. Okay, so where is the first x-intercept on the positive x-axis? So let's look at the positive side. Yeah, where is it? Pi over 4. Right here. That's your first x-intercept. Okay, how often do they occur? So the first one's at pi over 4, the next one's at 5 pi over 4. What is the distance between pi over 4 to 5 pi over 4? Pi. Okay, so they occur every pi units. Can you guys see that? If you did 5 pi over 4 minus pi over 4, that 4 pi over 4, which is pi. So 5 pi over 4 minus pi over 4, 4 pi over 4 simplifies to pi. So it's pi units there. Okay, so the way that we write the x-intercepts is an equation. It's very similar to what we did with the unit circle. So it's pi over 4 plus, and instead of 2 pi n, they occur every pi n. Okay, so this is your equation. And this is where n is any integer. You don't have to write that every time. Okay, I just want you to know that's what the variable represents. So it's pi over 4 plus pi n. Okay, and then our last step is to identify the maximum and the minimum values. Okay, so we're going to do something very similar. So the max and min occur between the x-intercepts. So again, just find your first maxima, which would be here on the positive axis, and where does that occur? At what x value? Not pi. At 3 pi over 4, right? So right here at 3 pi over 4. So we would say they occur at 3 pi over 4 plus. Now let's see how often they occur, right? Yeah, it's 2 pi, right? From here to here, it's 2 pi. From your max to your max. Remember how we did that earlier this week? Okay, so I'm not going to write it on there because I don't want you guys to ruin your graph. I'm going to show you this. So from here to here, it's 2 pi. Okay, that is going to be your period. Remember that's how we calculated the period in our packet? We went from maximum to maximum. So anytime you're calculating this, it's 3 pi over 4 plus 2 pi n because it's the period times n. And those have a value of 1. Okay, so it's plus 2 pi n because 2 pi is the period. Okay, so if you had to write this for a period that was different than that, you would do like your max value plus the period times n. Okay, your min value plus the period times n. Okay, and when we say this min value and this max value, it's the x value where it occurs. Okay, so let's do the same thing for the minima. Okay, so what's the first positive minima that you encounter? Yep, so it's at 7 pi over 4 right here. So it's just 7 pi over 4 plus 2 pi n, and then they have a value of negative 1. Okay, so once you get that written down, I want you to do the first 2 steps on part B. All right, so what's your amplitude? 1. So remember, if you don't see anything in front of the cosine, your amplitude is 1. Okay, and if you don't see anything in front of your x, your period is 2 pi. Okay, what is your phase shift? What is h? Negative pi. So h is negative pi. So that means you're going pi radians to the left. Okay, so if you are shifting all of those pi units to the left, then when we are filling out our table, remember how we have to subtract the phase shift from the period? Okay, so what we do is the period plus h, and your h is negative. So 2 pi minus h, or minus your pi, plus a negative pi, is going to result in pi. Okay, so this is where you're going to end. If h is negative pi, this is where you're going to start. Okay, so let's make this table. So it's x and g of x. Okay, so you're going to start at negative pi. Okay, so you start at your h. We've already calculated the n, so that's going to be pi. So it's always starting at phase shift, ending at phase shift plus h, which we already calculated. What is halfway in between negative pi and pi? 0. What is halfway between 0 and pi? Which means halfway between these two is negative pi over 2. Alright, so then let's fill those in. Okay, so this is cosine. So remember, cosine starts at the max. Great. Okay, and it ends at the max. Halfway is the mid. So can you guys fill in that table? Okay, so your max is always going to match your amplitude. So what was our amplitude? 1. So we start at 1, we end at 1, and our mid is negative 1. And then halfway in between are the zeros. Remember I said you can, there's 2 things you could use for your x scale. You can use the phase shift, which in this case pi is pretty big. Usually I choose the smaller one. So for the x scale, we're going to use the period divided by 4. So if we take 2 pi and divide it by 4, you get pi over 2. So I'm just going to scale mine by pi over 2. So I'm going to go 1 pi over 2. What's 2 pi over 2? Pi, yep, 1 pi. 3 pi over 2, what's 4 pi over 2? 2 pi. 5 pi over 2, 6 pi over 2, reduces, 7 pi over 2, 8 pi over 2, 8 divided by 2 is 4. Okay, and then, so really, every 2 units is pi. So those are going to be a little bit easier for you to label. Okay, if you went by, you could go by pi, just so you guys know, you could go by pi. You're just gonna, you get more of a frequency, and that would be fine. Okay, I just choose the smaller one between the period divided by 4 and your scale. Okay. All right. So at negative pi, I'm at 1, and I'm gonna scale mine by half again. If you like just doing the 1 there, that is okay with me. Okay, and then at negative pi over 2, which is here, I'm at 0. At 0, I'm at negative 1. At pi over 2, I'm at 0, and pi, I'm back here at 1. Okay, so this is one cycle. This is one period here. Okay, now we have to continue the pattern. How are you doing at continuing the pattern? Are you doing good about that? So see how these are 1 apart? So I go to an intercept to a max. So then I'm going to have an intercept and then a min. And then an intercept and then a max. An intercept, then a min. And then an intercept. Okay, so I'm just doing that whole thing. Go back. That is a little shaky here. And that's why I do it in pencil first. Okay, and then on this side I'm in a max, so then I do an intercept, then a min, intercept, max, intercept, min, intercept, connect. Curve it here, curve it there, curve it here, curve it there. How are you guys looking? Feeling good about those? Yeah. And then if you want to go over it, that is fine. You do not have to. I do this for you. All right. So identify the x-intercepts. Where's the first x-intercept that's positive? Pi over 2, right? So from pi over 2, this is 1 pi over 2, 2 pi over 2, 3 pi over 2. So the distance from pi over 2 to 3 pi over 2 is pi. So how often should they occur? Every pi units. Okay, so that means you have pi over 2 plus pi n. Okay, this is what you have to write for your intercepts. Okay, the things that I'm like clouding in here, that's what you're gonna do. Okay, now we're gonna do the max and the min. So where's the first maxima? At what x value? It is at pi, and what's our period? So it's 2 pi n, and they have a value of 1. Okay, where is the first minimum? At 0. So I would accept several answers for this. You could do 0 plus 2 pi n, which 0 plus 2 pi n is 2 pi n, or if you did 2 pi plus 2 pi n, that would be fine as well. Okay, and they have a value of -1. Okay,